Diabetes is a chronic disease that occurs when the pancreas doesn't produce enough insulin or when the body doesn't efficiently use the insulin it produces. The effect of uncontrolled diabetes is hyperglycemia. Three main types of diabetes are known. Type 1 diabetes, formerly called insulin-dependent or juvenile diabetes, is characterized by the absence of insulin synthesis. Type 2 diabetes, formerly called non-insulin dependent or adult diabetes, has its origin in the body's inability to use insulin effectively, which is often the result of excess weight or physical inactivity. The other type of diabetes is gestational. This corresponds to a hyperglycemia that is detected for the first time during pregnancy. Insulin is a hormone made by the beta cells of the islets of Langerhans located in the pancreas. It's necessary to help glucose enter the cells of the body and be used to produce energy. It's stored in the liver and muscles to be used later and maintain constant blood glucose levels. If we don't produce insulin, it's necessary to inject it several times a day and before each meal so that the body can function normally. Insulin can't be taken orally because the digestive system would destroy it. Currently, human insulin is mainly used to treat people with diabetes. Human insulin has a structure identical to that originated by the human pancreas. It's produced by incorporating human genes for the production of insulin in special bacterial or yeast through techniques based in genetic engineering. Glargine insulin is an artificial version of long-acting human insulin. Mechanism of action regulates the metabolism of glucose. Insulin and its analogs reduce blood glucose levels by stimulating peripheral glucose uptake, especially by skeletal muscle and adipose tissue, and by inhibiting hepatic glucose production. Insulin inhibits lipolysis in the adipocyte and proteolysis and stimulates protein synthesis. The results obtained indicate that when you have hyperglycemia and you administer insulin, it lowers blood glucose levels. However, when you have normal glucose levels and you administer hypoglycemic drug, the blood glucose decreases considerably, unfavorable to the state of health. When there are high glucose levels and insulin is administered, the glucose decreases. However, when administering a new glucose load, the insulin can no longer control it, and it rises again, reaching higher levels than the initials. When we administer insulin intraperitoneally, it decreases the concentration of glucose in blood, and if we return to administer subcutaneous, the glucose decreases even more. Insulin glargine is a slow and long-action insulin analog produced by recombinant DNA technology in E. coli. It differs from human insulin by replacing the amino acid proline with glycine in the A chain. Binds to specific receptors present in insulin sensitive tissues such as liver, adipose tissue, and muscle. This union affects the metabolism of glucose but also of proteins and lipids. Glucose decreases blood glucose by promoting glucose uptake and its use by glycolysis or by stimulation of gluconeogenesis. It also inhibits hepatic gluconeogenesis. Lipids favors the transport of carbohydrates and their accumulation in adipose tissue by stimulation of lipoprotein lipase. Stimulates the deposition of triglycerides. In proteins, it favors the capture of amino acids and the synthesis of proteins. It's soluble at acid pH, precipitates at physiological pH by subcutaneous administration. The microprecipitates form slowly and continuously, release small amounts of insulin over 18-24 hours. It achieves its maximum effect in 5 hours. It's a partially metabolized in subcutaneous tissue under a liver bead means of insulin glutathione transhydrogenase.